So thanks everybody for coming. I'll share my screen here. Yeah, that's the one. Let me move it over here. Anyway, all right, let me get started then. So the idea of these, this is the guide that's focused on actually creating your own neural net and training it and then using it in your applications. And the style of these guides is, background material and ideas, but then there's embedded little snaps. So this is the very first one. And I should warn you already that the results are going to be very disappointing, but that's part of the point of this first exercise or something. So I'll make the blocks a bit bigger here. Okay, so one of the things about the style of this whole library is to have both sort of the simplest possible blocks and also the most full-featured ones. So what we're starting with is the really relatively simple ones. It sort of has the minimum amount of information. So this is saying, I want to create a neural network, and in this exercise, the point of it is to figure out square root, which you obviously don't need deep learning to come up with a square root, but I think it's a good illustrative example. And it's saying that I want a network in which the number goes to 100 different nodes or neurons, and then from those 100 it goes to 20, and then from 20 to 1. So, and then once it's created, it'll say the summary. So here's the summary. And if I show it to you in a little bit easier way, you could see that it has what are called dense layers, where dense just means that every neuron's connected to every neuron in the layer next to it. So the first layer it requires 200 different parameters, 200 sort of weights, and the next one 2020 and so on. So the total is so it's a rather small network right here. The system's capable of tens of millions in the browser, and of course, people make models with 100 billion parameters these days. So the next step is, by the way, I should maybe explain, I'm going to demo things for about 10 or 15 minutes, and then I'll let you guys explore things. So the next step is to create the data. So I just came up with some numbers, and then squares of those numbers. But here's the tricky thing. What I'm doing here is I'm saying the input is the squares and the output are the numbers. So that's why this is going to be computing the square root, because it's going to be getting, like, the first number it gets is 25 and the answer is 5 or something. And you could do this incrementally, you could add more data, but here it's saying, just override anything that was there before. And you could create data for different models if you're doing multiple models at once, but all models is just the default. So if I click on this, it'll just say the data has been sent to the, for people that are curious, by the way this is working is there's a kind of a hidden iframe, and that the snap is talking to that iframe, and that iframe is running TensorFlow.js, which is able to run this very fast because it's able to access the GPU and so on. So now I'll start training it. And at this point, you can't see much of what's happening. I could open up this panel and we could see that it started with a huge error, and now the error is dropped to still a fair amount. 100 is a fairly big error. And in this panel, there's a lot of different things you could do. You could save things, you could change parameters, you could experiment at this level, but I'm just going to return to snap. And at any point, even though the model's not been trained, you could ask for it to make predictions. And this is showing how badly it's doing, that it thinks the square root of 49 is 0.7 instead of 7, that the square root of a quarter is 0.11, and square root of 900 is 10. So it's not doing very well. And if I click on it again, a tiny bit better, it's training in the background or something. So the only advantage of this first example is to show that getting these things to work requires some fiddling with what's called the architecture, like how many different layers there are and how many neurons in each layer, and also some of the other parameters that are called hyperparameters or something. So if we look at this, we see that I think it's finally finished. Yeah, 500 learning steps, but it wasn't making much progress after the very beginning. So this was, as it says here, this is doing a really bad job. Can you improve it? So a student could fiddle with this, but then the next exercise is the one where I spent some time trying to come up with a better values for doing this. So let's zoom this. All right, so there we go. So so this time I'm making a bigger network, 100 nodes to 20 to 10 to 5 to 1, and I'm giving it an optimizer. In other words, a way for it to adjust the learning rate more cleverly so that it isn't just learning at a constant rate. And otherwise, it's sort of the same kind of thing. And if we again look at this, we see this time it's just not that many more parameters, because most of what I've added is fairly small, 10 to 5 and so on. But so the size of it isn't what's better here. But let me show you a fun thing that's, by the way, I have to adjust something. 1 second. This should just work. Everybody still see the screen, right? It's still working okay?
We can see it.
Yeah. So so the first, I was going to show you this really funny idea, which is you could ask for predictions even before you've done any training. So every time you create a model, all the parameters are just randomly initialized, so they're just totally random guesses as to what the square root of 7 is minus 0.8, and the square root, it doesn't have any idea what's going on. But we'll play with this in a second. But this is actually in a forever loop with a little bit of a wait. So we'll see as we do things, it'll start to liven up. So one of the things that everybody talks about with these models is they need a lot of data. And before we had, I don't know, 30 or 40 numbers. So here I'm just making 10,000 numbers from anywhere from 0 to 40 in that range. So, but that doesn't change this. But now with the learning, we'll start it, and we can see this is already starting to improve a tiny bit, that these numbers are starting to make a little bit of sense. And that I'm using a more advanced version of the training thing, which says, this time I'm only going 200 times, partly because it's a bigger model, so each time, but also I happen to know that it more quickly is going to converge to something sensible. Also, if you're going to have it trained for a lot, you might want it to just stop if it's not making any progress for a while, and it's learning at initially at least a slower rate. But this other idea is that it's not taking all 10,000 numbers for training. It's using 8,000 for training, and then the rest to just provide some validation that it's working right. By the way, this is starting to look a bit better. Oh, actually, I'm sorry. What this is displaying is, this is the it's really, this is the square root of 49, the square root of 0.25. So these are the correct answers at the bottom. And as you can see, it's starting to get closer to something close to it. And if we open up this panel again, we could see that this time it's running a fair amount better, but it is a bit slow because we're saying 200 and it's only gotten up to 11 here. By the way, it's usually faster on, I don't know if it's because other things my computer's doing or Zoom or whatever. So while that's running, and we could again, you know, see that it's getting closer. This is getting close to 7. This is getting close, not so close to a half. It's getting close to 30. This one might be having the harder time because if you think about this having picking random numbers. So oh, I see. So it's picking random numbers between 1 and 40, but it's picking them with, I don't know why I didn't just, I think at the time I didn't know that this pick random, if you use a decimal point, you don't have to go through all that little extra work there. Anyways, the point is that there's not that many small numbers. So that's maybe why this B column it's not very close at all. While the square root of 900, it's getting really close. The square root of 49, it's getting really close. So here's another thing you could do, which is while it's running or after you run it. So what this is doing is it's for all the numbers, it's making a prediction and displaying that in red, and then picking up the original numbers and displaying them in blue. So if I click here, oops.
Okay.
Did I scroll too far? Yeah, here it is. So we could see that they're pretty close. The two are doing pretty well. But remember, it's only being trained on numbers in a certain range. So I think here's the point where it's starting to get beyond the range. This is called out of distribution, OD, whatever. And we can see that it's for numbers that are much larger than its training, it's not doing very well, but on the training data, it was doing really quite well. So I think I'm going to stop, let you guys play for 10 minutes or so. And then I'll show you, there's a lot more advanced things, and there's also things coming up where it's not synthetic data like square root, but actually real data that might be interesting, so that the trained model does something that is more interesting. So unless somebody has some questions or problems, why don't we start again at 25 after. maybe while this is going on, I'll answer some of the chat comments. So Mark asks about using sort of a Monte Carlo analysis to figure out searching for the right scenario, and that's actually at the very end of this document. There's a search routine that is very much in a sort of Monte Carlo style. So yeah, in terms of interactions with sprites, I think I'll talk about that later. Somebody tried to remind me to bring that up, but I think it'll make more sense when we've gone further.
Ken, I'm very new to Snap. How do I find your library? I'm in libraries and import libraries.
Oh, right. So so the easiest way to do this is with the this guide that I sent at the top of the chat. But it says here at the top of the chat too that you could either import all of these blocks as a library. So if you click this, you would download it and then import it to Snap. But there's also a project version, which I think I have sitting here. Right. Do people see it when I change tabs, or am I still on the other tab? Do people see this new tab?
You're in great shape.
Yeah. So this new tab is a little bit like these kind of Jupyter notebook sort of things. So the idea is that each block is presented with an example and a little comment explaining it. And this is a simple version, this is a complex version, simple version, and so on, complex version. So this is another way to introduce the library. And the library that you could just pull into any, import into any Snap project looks like this. And you could either use the project that the library that I showed the link to, or you could just from here, you can just say export blocks, and then you just get the blocks without all of this. But I'll go back to here. So my view of this, by the way, is that this complements the kind of work we saw earlier in the conference on Snap and AI, where everything was built from just multiplies and adds inside of Snap, and there's much less black box magic. But the black box magic that I'm showing here could be speeding things up by 1 or 2 orders of magnitude. It provides all these nice tools like the graphing tools, and it's providing quite a lot of extra functionality, which is pretty important if you want to use this for your own projects for anything of any kind of complexity. So there's this trade-off between making things opaque and black box and getting the kind of functionality and performance here. But if you think about it, most students don't know how move forward works either, right? They just take that as a given. They don't know that there's some trigonometry underlying it or something. So 3 more minutes and I'll come back to. All right, well, let me explain a few more things now. Hopefully you got a little taste of what it's like. And this is still training. It's more than halfway. And one thing that's interesting here, I should have explained that, you know, by setting aside 20% for validation, we could see that the validation loss and the training loss are almost the same, which is exactly what you would like. That if your validation loss is much greater than the training loss, that means that the model has sort of specialized on just the data it was trained on and can't generalize to other kinds of data. So that's good. But on the other hand, remember when I made this little program to go outside the range of its comfort zone, it started doing pretty poorly. One thing that's you can see that square root of 49, it's really getting very good at. In the square root of 900, it's getting very good at. If it's bouncing around to the right things. The square root of 0.25, it's still doing a pretty poor job, though it was worse a little while ago or something. But let's move on here. So I'll try to stop this. Stop. Uh-oh. Okay.
Can I just quickly ask, have you tried that with negative numbers too?
Oh yeah, let's try it, even though it doesn't have any sense of you know, what the meaning of this thing is. So let's see, where did I put, oh, here's oh, right. So here's just a little test. So if we change this to, you know, -5 and change this to, I don't know, 99999 or something. Now, if I click here, it doesn't, for the -5, that's interesting that it actually predicted not a number, which is kind of clever. Anyways, you could just, you know, ask for as many predictions as you want. But this is just get predictions, but then what this is just trying to do is display the predictions with what's the true value. I mean, the true, yeah, this is, oh, right, sorry, I got it backwards. Not a number is because JavaScript or Snap, I mean, knows that the square root of -5 is not a number. So that's where that comes from, while it's thinking that it's around 1 or something. And then the correct answer for this 99999 is 316, and it was pretty far from it, because these are very far from the range it was trained at. But if we did this over again and we said, you know, train it with 10,000 numbers from 0 to 1,000,000, it probably would do much better. All right, let's move on here. So here's an example that I'm not going to show you because it takes a little bit of time, but what I'm about to list is about 4 or 5 different examples. And if any of them you're interested in for the next little practical session, you could try it out. So this particular one, the idea is it picks just random colors, just random red, green, and blue, and asks you what name you would want to give it. And then when you've done that enough times, it's trying to train from those 3 numbers to come up with the label that you've given it. So this is an example of classification, where the other one was computing a number. This is computing a category. And it doesn't do very well with just 50 examples, but if 50 are sitting there already available. But if you are willing to spend some time giving it more names of colors, it presumably could get better and better at it or something. And then to test it, just it'll generate a round number and tell you what color it thinks it is or something. So this next one is one that I particularly like. So if you take just the usual turtle polygon program, and instead of having exact numbers, you give a minimum and maximum, and same thing for turning, then like in this case, if you did it 100 times, you get these approximate pentagons or something. So, which is a little bit interesting. But if you then also pick, give a random range for the pen thickness and a random range for how much red, how much green, how much blue, you get, you know, and you also make them wrap around the screen, then you could get these kinds of much more interesting kinds of designs. So there's only 12 numbers that'll, for any image that's produced, which is again the minimum, maximum you're going forward, minimum, maximum you're turning, minimum, maximum pen thickness, and then for the colors. So the idea of this one is that it's supposed to learn from those 12 numbers how you would rate it. So it starts off and it gives you as many examples as you're willing to look at, and you just click on the, you know, 3 stars, 1 star, 5 stars, and then you click a button to say, okay, now start training to see if it could predict how I would rate things. And then once you've got it doing a decent job of predicting how you would rate something, you could do things like have it generate, not display, but generate 1,000, not images, but sets of 12 numbers, and figure out which one you would like the most or like the least, and show you, you know, what it thinks would be your favorite out of those 1,000 or the ones you hate or something. So it's kind of a fun example. So if that appeals to you, try this when we switch to the practical session. This is one where I've used a pre-trained model that Google made called the Universal Sentence Encoder that'll turn any bit of text into 512 numbers. And I had it, there was a little database of like 60 or so questions and answers about, in this case, about Snap. And then it tries to, if you ask a question, it'll try to find which question that it had been trained on that was the most similar, and then output the index of the answer that's associated with that one. So you could play with that. You could have it, of course, have questions and answers on other things. And there's other ways to do questions and answers, but this is one that where you're building it yourself from. And this is a similar one, except that instead of associating questions with answers, you're associating some property of a sentence. In this case, whether it shows confidence or lack of confidence or is neutral. And you could train the model on, again, you know, it doesn't work very well because it's trained on only 60 examples, but it does a surprisingly good job for so little data. And again, it's just trying to categorize a new sentence into one of those 3 categories of confident. Or actually, I think I didn't use the labels. I used -1 to 1, and then it'll predict a number between that range as to how much confidence or lack of confidence it is. And then this is just an example of how, once you've made a model like that, how you could use it. And then there's a bit more about trying to explain a bit more what's going on and how, you know, if you say a model is 9994, then this is what it'll look like or something with 8 inputs. Right. And then, you know, what XKCD has to say about it. So, And then this isn't important for today, but it's once you've gone through this training, which in some cases, you might want to leave your laptop overnight, so it's trained on a lot of data and gets pretty high accuracy. You could then save it, and then there's blocks for loading it, so that you don't need to go through the training when you're embedding it in your application. Yeah, and then there's just there's an example with a tic-tac-toe game where the given any board position, it's learned is X or O likely to win from this, and then what you could do to make it an intelligent player is just look at all the legal moves and pick the one that it's more likely to win from. And it turns out that Don Knuth did this, I think 1959 or something. He made a little video talking about one of his first programs, which was learning to play tic-tac-toe. Noughts and crosses, I think, is what it's called in some parts of the world. And then, like that question somebody asked, this is an example, don't worry about it today, but the fact that it's possible to have it search for good parameter models, and you could tell it how many searches to make and what range of parameters and so on, and then it'll come back with which ones were the most accurate. So unless there's some questions, I think you should pick one of these that you're interested in, naming colors or rating these noisy polygon images, or question answering, or categorizing sentences, those kinds of things. I think the tic-tac-toe one is a bit too complicated for a short amount of time. And also, there's a little discussion here about pulling in real world data and how you could do it. And I give this example that didn't really work very well, which was whether there was a connection between previous weather patterns and incidence of influenza or something. But there's all these data sets where you could just sort of pull them in and bring them in, and then have it try to predict whether there's going to be more or less people with flu in a particular region based on the weather patterns of the previous few weeks. If there is a connection, that's the kind of thing you could look for there. Good. So unless there's questions, recommend you pick one of these, and we'll meet again in at 16:50. So you got 12 minutes to play around. So if people are getting error messages, I guess the best thing to do would be that if I stop sharing my screen and we look at what's happening. So I'll stop sharing.
Ken, this is Bob, of the same last name.
Right. Let's see.
Where would be the simplest model to start with? Which would you recommend?
Yeah, I mean, the rating one is pretty simple. It's just basically trying to learn, given 12 input numbers, what rating between 1 and 5 is the most likely. And the problem is you'd have to spend like 5 or 10 minutes kind of rating, 20 or 30 of these so that it gets a chance to have some actual data. But then you can see how it's working, and you could open it up and see how it's doing it. I mean, in some sense, the first exercise was meant to be the simplest, which is with just artificial mathematical things. Like, as a matter of fact, I think I got the idea because one of these tutorials even just said, you know, suppose, you know, the output was always 2x plus 1, you know, let's see if we could get the model to learn that. But that just seemed too kind of boring. So instead, I thought square root would be more interesting and more challenging.
So when you say the rating one, are you referring to the Pentagon one?
Yeah, right.
Oh, okay, thank you.
It's not always a pentagon. It all depends on the angle
Yes.
ranges. But yeah.
Yes, thank you.
I like that one too because it seems very appropriate for Snap and thinking about turtles and all that.
Hey, Ken, I was trying the name, the Polygon one,
Right.
simple model. Sorry, so the simple model that names colors. And the error I'm getting is input expected a batch of elements where each example has shape 3 from tensor shape, but the input received an input with 50 examples, each with shape 1.
All right. Well, maybe I'll walk through it, how it should work, unless somehow it's been broken. Because the 3 would be the red and the green and the blue components. Let's see. Where's the? Well, I guess this will. This work? Well, maybe I don't even. Yeah, I have to share it. Oh, there we go. This is shape 3. Wow. Well, maybe I'll, as you guys are doing your thing, I'll have to debug this on the fly. By the way, one of the things, sometimes it's a little bit too constrained to see Snap inside of a frame like that. So here I just reopened it in its own tab. So we want to create the model. Are we even creating them? Oh, I see. So, oh, never mind. This is, let's edit this and see what's going on. So it is saying 3 input numbers. And then for the training, it's saying colors and color names. So is there something? Oh. So somehow all the colors became 0. So if you want to try it, it'll take a little bit of time. If you click here, and let's not do 100 because it'll take too long, but just say 10 colors. This will create the training data. So let me, okay. So I'll call that kind of green. Oops. And that's black. And that's black or something. And that's green. They're not being very random. Call that red, except I might have misspelled it. I'll just call it red just because I don't want too many different colors right now. Green color. Okay. So if we look at colors now, it actually has the red, green, and blue, and then the names the names. Oh, wait. Oh yeah, color names are here. So, sorry, somehow the sample data got clobbered there, but you could create your own data and then train, and then it'll start training.
That's pretty cool.
Yeah.
Thank you.
By the way, it'll think there's a color called red and there's a color called red. It won't know that those are misspellings, but anyways.
It was a rad color.
Yeah, right. And we can see how it's doing here. And why isn't it showing? Trying to snap. Oh, training started. It says. I'm not sure why I'm not seeing much of a graph here, but we could. So it sends the colors and the color names, and then the labels are the color names with all duplicates removed, because those are the possible labels. And otherwise, it sends this data. Once the data is sent, it does this training. And the way I set up this training block, if the output are labels, then it just turns it into the appropriate numbers for the model to use, since all these models only work with numbers in and numbers out. But for labels, you could turn it into if it's a third color, it'd be 0, 0, 1, 0, 0 out of 5 or something. So it does that for you. And then it should, yeah, here we go. But that's something's broken here, because I said name this color, and it's saying all of these colors have a 0% chance. So I don't know why it's not training, because if I open this up, I would have expected to see the training happening. Here's the model that we created. And so maybe if I just start it up again. Oh, here we go. I don't know, but now it's starting to do the training. And now we're seeing, because this is a classification thing, we're actually seeing how accurate it is. So it's pretty accurate already, that it's getting it about half right, which is out of 5 choices is not too bad. On the other hand, it has so little data that it's not very reliable. But the error is dropping a bit. So now if we return to Snap and I say name a color, it thinks that's green because it had very little data and very little training. But I do it again, and that one, it's 69% it's green and 29% it's black. It is a dark green, but it clearly can't do very good with such little amounts of data and hasn't finished training. So. I don't know how those colors became all zeros. Yeah. All right. Well, so maybe I should find out how it's gone, or if people have questions or ideas, or
I will say I really like your the displaying the support window option, so you can pop in and see and kind of, you don't have to see the model, but you definitely can. So, I could see that as a great extension where you start messing around with some of this with students, and then you actually can have them start making some adjustments in the model and just see what happens with things. I think that's brilliant.
yeah, thanks. I mean, one of the things that's this one is that you can look at what all the options are here on this page, and then decide to there's buttons. So you could, if for those that find it easier to just sort of experiment or twiddle directly with some of these parameters, you could do it all on this page. But remember, the page was sort of all initialized coming in from Snap, and you go back to Snap or something. But there is that question of whether you just want to keep fiddling with your blocks, or whether you want to just experiment a bit right here. Let's see. Trying to think. I mean, this was pretty much what I wanted to show you and have you guys try. Did anyone? Maybe I'll make sure it's clear with this one. So the I like that one. I'll give it 4 stars. I don't like that one very much. Give it 2 stars. 2 stars. But the idea is that after you've done that, you could press one of these buttons. So if you've done some of it, think you've done enough, you could have it start training, or do additional training, and then you could go into the mode where it's rating things. But I think I set it up so that you rate it, then it tells you what it thinks you would have rated it or something. Anyways, so that's the way this works. And let's see.
How would you change the angle or length parameters in that one?
Right. So let's look at the code here. So let's see, did I set this up? Oh yeah. So no, that's not what I want. Sorry. Let's look at how we actually draw these things. So right. So let's look at the current configuration or something. So the way I set it up is these are the 12 numbers, and there's many advantages to doing this kind of training where the numbers are all in sort of the same range or scale. So everything is a number between 0 and 1 here, so that for red, whatever number, the fifth one, this is the red, but it's multiplied by 255. And then for the step, it's just 100 times whatever it comes up with here. But for the turn, it's I forget why I did it this way. Oh, it's trying to come up with a, what's it, 180 times at minus 9. Yeah, so it's got a turn between 0 and 90. But if you wanted it, so this was set up so that you don't really have much control. It's just doing it. But if you change some of these numbers, then like the angle, you could control the range of the angle, for example, and leave everything else to be random or something. I mean, the other idea is that all that this is doing is taking this current configuration and making it into an image. So if you had any other kind of turtle program that would take these 12 numbers and make an image, you could use that instead of this noisy polygon thing. Or you can make one that, you know, suits your interests as well.
Where did this model come from? I mean, how do I find it, in other words?
Right. So let's see. Well, first off, yes. Oh, from here, of course. Oh, I see what I'm doing. Here, let's just do it. Well, I have some kind of weird network problems, so that if I use I was doing everything on my local server, and if I do it with the
Other people didn't have a problem, I guess, but I couldn't figure it out.
well, so if you click on this, it'll launch inside of this frame. But then if you want, if you, sorry, it was a little hidden. If you click on this, open this in a new tab, then here's your URL for the project, and I'll put it in the chat as well or something. Oh, by the way, you can, that's still using 7.3.1 because I haven't finished making sure everything's working in 8. But for this project, it doesn't really matter whether it's which version of Snap, but I'm almost certain that I also put this in the Snap site somewhere. I mean, you know, I published it as a regular Snap project without using my version of it or something. So if I say my projects, I would have thought it would be in here. Well, oh no, there's a whole bunch more. Oh, I could search, so I see. Noisy. There it is. Yeah, so here's the more official URL that's just plain Snap without any of my stuff.
Ken, you got about 30 seconds left. Just want to see if you want to say
Yeah,
something.
so any final questions? I'm happy to, you know, offline, send me email if you got questions or if you try it and you have problems or suggestions. But thanks for participating, and good luck with trying to play with these things.
Ken,